Hello, today we are going to do section 3.3, which is going to cover how you can convert between radical format and actually into a rational exponent or a fraction exponent. So by the end of this lesson, hopefully you can explain what a rational number as an exponent means, and also be able to rewrite between a rational exponent form and a radical form, or vice versa between radical form and exponent form. So the word rational, this word, if you look at it, has the word ratio inside of it, which means a fraction. So fraction exponents are called rational exponents, and they are just another way to write your roots. So instead of writing it in a root format, you can actually write it as an exponent. So the way this pattern works is for the exponent format, the top or the numerator of the fraction, this represents the power. Maybe I'll write this a little bigger to the side. So this little n right here, this would represent the power on the base, and the denominator represents the root. So when you are rewriting from fraction form, since this number is the power, it's going to go on the base as a little exponent, and then this denominator is the root, and that's going to go inside the root type. You can write it one of two ways. You can do the root on the outside with the exponent on the inside, or you can do the root first and then the exponent on the outside. It works either way. Sometimes depending on the numbers you have, it might be better to do this way. Sometimes it'll be easier to do it this way. Just kind of depends on what you are looking at. So let's try just taking some examples where we have some numbers first, so you can see how it works. Ones that have a 1 on the top, that's like a power of 1, but you don't really need to write the power of 1. So remember, the top number is your power. So you'd have 5 to the power of 1, which is just 5. And then here the 3 is saying it's going to be a cube root. If we have a different number than a 1, though, you will want to write it. So the top number is your power, so we have 5 squared. And then the 3 is the root type, so we have a cube root here. So again, you can do the cube root on the outside and the square on the inside, or you can do the cube root on the inside and the square on the outside. Either of these will work. So, hey, let's look at some examples. We're just going to practice just rewriting right now. So we're going to go from exponent form into radical form. So remember, radical form means your square root format. So you're first going to take your base number. So in this first example, our base is 3. And then remember, there's two different ways you can write it. So the first way is to take the power. So the top number is your power, and we're going to write that as the exponent. And then take the bottom number, and that's going to be the type of root, and that can go over the outside of it. So you have the 5th root of 3 to the power of 6. Or you can write it the second way, which is to do the root first. So take that 5th root over the 3, and then the power can go on the outside. So you can have the power of 6 on the outside. So either of those are fine. You can write it either format. Okay, notice this one, we have the same numbers, except we have this negative here. And then notice the difference on number 3, how we also have the same numbers, but this time we have parentheses and a negative. So this is a really important distinction that you need to be able to make when it does not have parentheses on it. So like this one does not have parentheses around that -3. This power or exponent is not actually affecting the negative. So really kind of what this means is it's like you have a -1 in the front times 3 to the power of 6 over 5. So that -1 is kind of separate. So you're going to leave the negative on the outside, and then you can do your 5th root of 3 to the power of 6. Okay, so that negative is just going to stay out front. Or again, you can do this format. So you'll have the negative outside, and then you'll do the 5th root of 3 to the power of 6. So remember, when the negative is not inside parentheses, it's going to stay out front. Versus this one that does have parentheses, that means the negative is being included with the 3. So on this scenario, the negative is going to stay on the 3, and you will do the 5th root of negative 3 to the power of 6. Or you can do it in the other version where you have the fifth root of negative 3 and then the power of 6 on the outside. So just notice the difference between how they're written, and you do want to have, when you have those parentheses, that negative is going to stay on the inside, and when there's no parentheses, that negative stays on the outside. It's a really easy thing to accidentally get wrong if you're going quickly, like on your test or your homework, so just be aware of that. It also is the same in your calculator. So if you just typed negative 3 into your calculator without parentheses, and you should have done it this way, you're going to get the wrong answer. So that's why I always tell students to put parentheses around everything if it has a negative on it. Okay, so let's look at the next row. Notice again, they're all the same numbers, but we have a negative on the outside and then the negative inside the parentheses here. So your first step is to take your 4, your base, and then the top number is the power, so we have 4 squared, and then we have our cube root. Or you could do it the other way. You could do the cube root of 4 being squared. Okay, now this one, since the negative does not have parentheses around it, it's going to just stay on the outside, and then we will have our 4 being squared, and then the cube root around it. Or you can do the other way. Keep your negative on the outside, but you can do the cube root of 4 being squared on the outside. So again, either of those formats works. But on this one, we do have the negative on the inside, so that means the negative is going to go inside of all of the square roots and the powers. So we can have our negative 4 squared and then our cube root on the outside, or we can do our negative 4 with the cube root, and then all of that being squared. Okay. So again, just be careful with that distinction of no parentheses versus parentheses. Okay. So on all of these, we were going from exponent form to radical form. Let's reverse it. Let's go from radical form into exponent form. So there's a typo there that should say exponent form. Fix that. Okay, so when we're writing it, you're first just going to take that base number. So here is our base 5, and then the power, remember you're going to have a fraction. The power is going to go in the numerator, and whatever the root type is goes in the denominator. So we get 5 to the power of 3/8, and you're done. So then on this next one, notice that the power is not written. If there's no power written, it's just a power of 1. So we're going to have our 7, and then a power of 1 on the top, and a 3 for the root goes on the bottom. And notice the negative is written outside, so that negative is just going to go out front, and there's no parentheses in that scenario. Okay, let's move on to the next one. Take your base number 4, and notice this time the root is first with the square on the outside. Again, that's fine, but find your power. That's going to go on the top, and then the root goes on the bottom. So you get 4 to the power of 2/3. Let's try a couple more. Notice this one doesn't have an exponent or a root type. So we never write power of 1s. Sorry, I'm losing my voice today. And then we also don't ever write the 2s in a square root. So if there's not a number written on your root, that means it's a square root. So take the 6 for your base, and then our power is a 1, and our root type is a 2. So we get 6 to the 1/2. You notice on this next one, the negative is on the inside, so that means when we write our base, we want that negative 8 to be in parentheses, just like how up here, on this one the negative had no parentheses, but this one it does. So on this problem, the negative just stayed out front with no parentheses, but on this one, since it's on the inside, we do need those parentheses in order to write this in the right format. So once we have the parentheses around it, we can do our exponent. The power goes on the top, and the root type goes on the bottom. So we get negative 8 in parentheses to the power of 2/3. And then this one's just with letters, but it works the same way. Take your base, which in this case is a B, and then we're going to do a power of C over a root A, and that would be your answer. So not too bad, right? Okay. Let's just do a few more. This time, we're actually going to evaluate, which means they want you to actually simplify and get the number, not just leave it written in either radical form or exponent form. So sometimes when we have these exponents, it's kind of hard to think, what does 36 to the power of 1/2 mean? But when we put it into radical form, it might make more sense. So if I look at this 36 to the 1/2, my power is a 1. So that would be like 36 to the power of 1. And then I have a root 2, or just a square root. So really this is saying, what's the square root of 36? Well, we know what the square root of 36 is. It's 6. So putting it from exponent form into square root form can help make more sense sometimes. Okay, looking at this one, you have 64 to the 1/3, which again, just thinking about that might be kind of weird and we don't know what the answer is to that. But if we put it into root form, take our 64, this would be a power of 1, but we don't really need to write it, and now a root of 3. So really this is saying, what's the cube root of 64? Well, if you remember, 64 is a perfect cube. It's a perfect square and a perfect cube. So that's saying what number times itself 3 times is 64, and that is 4. 4 times 4 times 4. So that would be your answer. Okay, on this next one, we have 36 to the power of 3/2. So I'm going to write this in both formats, because remember we can do the power first, 36 cubed, and then do the root on the outside, or you can do the root first, so we'll do the square root of 36 and then cube it. So this is kind of how I was saying one way might be easier than the other to evaluate. If I look at this format first, 36 cubed is going to be a huge number. I can't do that in my head, so I would have to get a calculator out, and then I would have to take the square root of that big number. So that might not really be you could still do it, but it's not going to be the easiest method. But if I look at this method, I know what the square root of 36 is. So if I do this one first, the square root of 36, that would equal 6. And so then I would just have to do 6 cubed, which is 6 times 6 times 6, which is a lot easier to do than 36 cubed. I would much rather do 6 cubed than 36 cubed, right? Wouldn't you guys also? So 6 cubed is 6 times 6 times 6, which is 216. So again, sometimes just changing which way you write your power and your root will make the problem a lot easier. So if it's a perfect square and you're doing a square root, do that first before you do the exponent, because that will make your number smaller, which makes the exponent easier to do. Okay, notice this one, the negative is inside parentheses, so we need to kind of keep that in mind when we're writing it. So I have a power of 3 and a root of 2. So I'm going to take my base with the -9, the negative's coming with it, and I can either do -9 cubed with the square root on the outside, or I can do -9 with the square root being cubed. So just a reminder though, are we allowed to do square roots with negatives? No, we are not. So the answer to this one does not exist, or it's an imaginary number. So we're just going to write no solution on this one. So you can't take a square root of a negative number. So kind of a trick question there. Okay, let's just do these last 4 and then we'll be done. Okay, so on this one we have 27 to the power of 4/3. Again, thinking of that as an exponent, I just get confused. I don't know what that number is going to equal, but rewriting it into a root format, I can probably figure it out. So I'm going to do my base of 27, and you can either do the power of 4 with the cube root, or you can do the 27 with the cube root and then do the power of 4. So can you guys see which one would be easier in this scenario, the top one or the bottom one? So looking at 27, 27 is a perfect cube. So doing the cube root first will be easier than doing 27 to the power of 4. Because again, we get a really big number doing that. But the cube root of 27 equals 3. So this is really saying, what is 3 to the power of 4? Well, 3 times 3 times 3 times 3 is 243. So that would be our answer. So again, this format ended up being the easier way to do it. Okay, on this next one, we have negative 27 to the power of 2/3. Notice we do have the parentheses around it, so that means the negative is going inside with the 27. So we can either do that number squared and then the cube root, or you can do the cube root of negative 27 and then square it. So on this one, we do have that negative, but we're doing a cube root. So whenever it's an odd number, like 3, 5, 7, you can do negatives. It's only our even roots that we can't do negatives. So like up here, we had a square root. 2 is an even number. You can't take an even number root with a negative number. But we can do an odd number root with a negative. So if you wanted, you could do the cube root of negative 27 first, which if we did that, the cube root of 27 is 3, so the cube root of negative 27 is negative 3. And then you could square it, which negative 3 times negative 3 would turn to a positive 9. Or you could even do it this way. You could do negative 27 squared. Because remember, whenever you square something, you're saying to do negative 27 times negative 27. And if you square that, it's going to turn to a positive number, which you can take the root of. So I still think this one is easier though, just because 27 is a perfect cube, so that works out really nicely. Okay, here we have 49 to the negative 1/2. So we're going to take that 49 as our base. We have this little negative 1 exponent. We'll think about what to do with that in a second. And then we have our 2 root, which is a square root. So we can write it like this, 49 to the negative 1 with a square root on the outside. Or you can do your 49 with a square root all to the negative 1. So first, let's just think about which format is going to help us more. Looking at 49, we know 49 is a perfect square, so that means I can take the square root of it really easy. So again, I think this format is going to be the better one to pick, because if I take the square root first, the square root of 49 is 7. So now we just have 7 to the negative 1, and if you guys have been following along in our unit, that negative 1 exponent is saying to take this 7 and put it down into a fraction in the denominator, and then that power would turn positive. But we don't really need to write the power of 1. So this is really saying we have 1 over 7 as our answer. Or you could have you could have thought about it as being, if you do the negative 1 first, this is the same as doing 1 over the square root of 49. Put that down in the bottom, which is 1 over 7. So lots of different ways you can do it. You can do it in different order and it will still work out. But kind of combining that negative exponent rule that we learned last time. Okay, last one, we have 16 to the power of 10, and then a root 8. So if you do this, you could totally do this right now, and put it in your calculator. 16 to the power of 10 is going to be huge. And then you have your 8th root. So you could use your calculator, or notice if I put this into exponent form first, I can write this as 16 to the power of 10 over a root of 8. I can reduce that fraction. 10 over 8, if I take a 2 out of each, well, 10 divided by 2 is 5, and 8 divided by 2 is 4. That makes your numbers a lot easier to work with. So you could do it this way now. And again, you could put it into your calculator. Or you can do your 16 to the power of 5 with a 4th root on the outside. Or you can do your 4th root first of 16 and then to the power of 5. So that just makes the problem a lot easier, because now you're using 4 and 5 instead of 8 and 10, which is just a lot easier since the numbers are so much smaller. So looking at this, I do think this one is easier, again, doing the root first and then the power second. And that's because the 4th root of 16 is saying what number times itself 4 times is 16. Well, 2 times 2 times 2 times 2 is. So 2 times 2 is 4, times 2 again is 8, times 2 again is 16. So the 4th root of 16 is actually 2. And then we can do 2 to the power of 5, which is 2 times 2 times 2 times 2 times 2, which is 32. So reducing that fraction just made the numbers not so difficult to work with. So that's why sometimes switching it back to exponent form, reducing that fraction, and then putting it back into radical form can be beneficial. So hopefully you guys are feeling confident on going between root form to exponent form, and then from exponent form back to radical form, because just depending on the scenario you're in, one format might be better than the other. So if you guys have any questions though, please feel free to reach out to me. I can definitely help you, but go ahead and get started on your homework. Hope you guys are doing good. See you later. Bye.